Hello everybody, welcome to the introductory class of organic chemistry. Now, what is organic chemistry? Quickly, organic chemistry is the study of organic compounds and its derivative. Now, when we talk about organic compounds, we are talking about hydrocarbons, right? And hydrocarbons is a compound that is made up of just hydrogen and carbon. Now, in the study of organic chemistry, carbon is regarded or known as a major element, and there are three reasons why it is known as a major element. Number one, carbon can catenate. Now, when we talk about catenation, it means that carbon has the ability to form a straight chain. Carbon also have the ability to form a branch chain, and carbon can also form a ring-like structure. Now, it is these three abilities of carbon that is what is regarded as what catenation. Now, number two reason why carbon is known as the major element or regarded as the major element in organic chemistry is that carbon can combine with hydrogen, can combine with nitrogen, can combine with all the halogens with ease. Now, when we talk about all the halogens, we are talking about chlorine, we are talking about fluorine, we are talking about bromine, etc. Then number three, carbon has the ability to form either it is single bond, double bond, or triple bond. Now, these three characteristics of carbon, that is why it is regarded as a major element in organic chemistry. Moving forward, the next thing we're going to be talking about is the basic terminology we use for organic chemistry. Now, we are going to start with number one, which says is the homologous series. Now, what is homologous series? Now, homologous series is a family of organic compounds that follows a regular structural pattern which successive members differs from the previous by CH2 group. Now, trying to explain this, let's do this. One carbon atom is known as met. Two carbon atom is known as S. Three carbon atom is known as prop. 4 carbon atom is known as bot. 5 carbon atom is known as pent. 6 is known as hes. 7 is known as heps. Then 8 is known as ots. 9 is known as non. Then 10 is known as dec. Now, for example, let's look at met. For example, I will say that one carbon atom is known as met, right? Then 2 carbon atoms, right, is known as S. Now, let's look at alkane, for example. That this is an alkane, right? And this is ethane. Now, looking at these two compounds, this one is methane, this one is ethane. Now, if we subtract one hydrogen from this, we subtract another one from this, subtract this from this. Now 3 is gone, and we subtract this from this. So automatically, if we subtract all these 4 hydrogen, so we say okay, 4 hydrogen is gone, right? 4 is gone. Now, what is left here is C. If we subtract C from this guy, so what is left is just CH2, C and 2 hydrogen. Now, what it means in homologous series is that each successive members, they differ from each other by what? CH2. Okay. Now, the next thing we'll now look at is functional group. Alright, so the next thing we'll be talking about is functional group. Now, in functional group, I've put them on the board, right? Which is going to be easy for us. So when we talk about the alkanes, alkane is a functional group. Alkane has a single bond. When we talk about the alkenes, alkane is a functional group, and this is the molecular formula, and it has a double bond. What about alkynes? Alkyne is a functional group as well, and it has a triple bond, right? So moving back to the example we gave, our previous example of look at methane. This is a methane, right? And this is ethane. Remember, two carbon atoms is called Earth, right? It's called Earth, but the functional group is an alkane. So we attach the ending name to Earth, so this becomes ethane. Now remember, a one carbon atom is called met, right? So therefore, the functional group is an alkane. We add the ending to it, so this is a methane. Now looking at this structure very well, JAMB question will ask, or JAMB will ask, what is the structure for methane? Methane is tetrahedral in shape. You can see the kite shape. So tetrahedral in shape. So moving forward, let's look at this compound. We have double bond, right? So because of the presence of double bond, the two hydrogen on that will go, right? So what is the name of a carbon with three atoms, right? Or two atoms rather? It is known as Earth. So what is the functional group? It is an alkene, because alkene has a double bond. So add the ending to it. So this is ethene, right? So this is ethene, and alkene rather decolorizes bromine water. Okay. Now, what if we have something like this? What if we have something like this, and at the end we have OH, just like we can see here, alkanol. Alkanol is also known as alcohol, right? So if we have something like this, so remember that two carbon atom is Earth. What is the functional group? The functional group is alkanol. Add the ending to Earth, it becomes ethanol, right? It becomes ethanol. Now moving forward, I'm going to clean this again. And what if we have this alkanoic acid, is also known as carboxylic acid, right? What if we have something like this? Okay, let's say OOH, COOH, sorry, H. So this becomes Earth. What is the ending? Remember that this is alkanoic, sorry. This is alkanoic. Now add the ending name to this, so this becomes ethanoic, right? So this is an handful of the functional groups. There are many, and we are going to be reviewing them later. Now, the other terminology I want to show you is an alkyl group. Take note, an alkyl group is formed when an alkane loses one hydrogen atom. I repeat, an alkyl group is formed when alkane loses one hydrogen atom. For example, we have something like this. This is CH4, right? Or we can draw the structure as H, right? Now, if this guy loses one hydrogen atom, it becomes CH3, and we can draw the structure as H. So an alkyl, repeat, an alkyl group is formed whenever an alkane loses one hydrogen atom. Like in this case, you see that methane loses one hydrogen to give us CH3 instead of CH4. You have CH3. So this is now what? A methyl group. This is a methyl, and this is what? A methane group. So take note, this is methane, this is alright, methyl. So the next terminology is saturated and unsaturated hydrocarbon. Now note, for you to know this definition very well, saturated hydrocarbon, they are attached by a single bond. Then unsaturated hydrocarbon, they are attached by either double bond or triple bond. Let me show you what I mean. Now, for example, if I have this is an ethane, right? The number of the carbon atom 1, 2, 2 is 8. What is the functional group? Functional group is alkane. When you add it together is what? Ethane. Okay, let's keep going. Then I have something like this. This is 8 as well. What is the functional group? Double bond is alkene, right? So when you concatenate it, is ethene. So one more. Now this is 2 carbon atom, is also called it or it. Now what is the functional group? Triple bond is what? Ethane. Now we have ethane, ethene, and what? Ethane. Now how do we go about it? When we say saturated hydrocarbons, they are joined by a single bond. Saturated hydrocarbons are joined by a single bond, and as you can see here, there's no space for it to be filled, right? In the local term, we say its tummy is filled up, it's satisfied, it no longer needs what anymore, right? Then when we now look at this hydrocarbon or this organic compound, we see that they are joined by a double bond, and it still has space to accept more. It's not filled yet, it's still hungry. So for example, if I take away this double bond, I can have a space for what? Extra 2. So in this case, I can say that ethene is what? An unsaturated what? Hydrocarbon. Ethane is a saturated what? Hydrocarbon. Ethene is what? Unsaturated what? Hydrocarbon. What about ethane? Ethane is super unsaturated. Super. If this guy is hungry, this guy is very hungry. I repeat, if this guy is hungry, this guy is what? Very hungry. And you can see it has 4 more space to accept hydrogen what? Atoms, right? So I repeat, a saturated hydrocarbon or a unsaturated hydrocarbon is that one that is attached by either it is double bond or what? Triple bond. The white saturated hydrocarbons are attached by what? Just a single bond. Alright, so the last set of terminology I'll be giving to you is hybridization, bond angle, and sigma and pi bond. Now, in a nutshell, when we talk about hybridization, we are simply saying sp3, sp2, sp. I just want to go straight to the point. Now, all alkanes, take note, all alkanes have hybridization of sp3. All alkanes have hybridization of sp2, and all alkynes have hybridization of what? sp. Now moving to bond angle, we won't talk about bond angle. All alkanes have the bond angle of 109.5 degrees. All alkenes have the bond angle of 120 degrees, and all alkynes have bond angle of 180 degrees. I repeat, they have hybridization of sp for alkynes, sp and a bond angle of 180 degrees. For alkenes, they have hybridization of sp2 and a bond angle of 120. Then for alkenes, they have hybridization of sp3 and a bond angle of 109.5 degrees. Now, the last one is sigma and pi bond. I'm going to try to explain this in a way. Now, alkenes have the equivalence of one bond to be equals to a sigma bond, right? And they have pi bond towards 0. Okay, I know it's still shaking, but I'll try to explain. Then, okay, let me clean. So what I'm trying to explain is this. All alkanes, this is a methane, and methane is a member of the alkane family. Now, if you see a question that says, what is the sigma bond that is here? Now, alkanes does not contain any pi bond, right? But one of the bonds are equivalent to what? To a sigma bond. Now, sigma bond is designated like this. The pi bond is designated as your normal pi, right? Now, let's count the sigma bond that is present in methane. So, 1, 2, 3, 4, because we said one of these bonds is equivalent to what? To a sigma bond. So therefore, there are 4 bonds here, and pi bonds is 0. So we have 4 sigma bonds, pi bonds is 0. Let's take another example. So for example, if we are asked to calculate to number the sigma bonds that is here, how do we go about it? One bond is equivalent to a sigma bond. So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have 7. So therefore, the sigma bond here is what? 7. 1, 2, 3, 4, 5, 6, 7. What about the pi bond? Is what? 0. Now note that for alkanes have 1 sigma bond. That's one of the bonds is equivalent to 1 sigma bond, and the pi bond is what? 0. Now for this compound, let's recapitulate. That we have 1, 2, 3, 4, 5, 6, 7 sigma bond and what? 0 pi bond. Now note for alkenes they have alkene has 1 sigma bond and 1 pi bond. Alkene have 1 sigma bond and 1 pi bond, right? Alkene has 1 sigma bond and 0 pi bond. Why alkene have 1 sigma bond, right, and 1 pi bond. So for example, if you have something like this, remember alkenes have double bonds, right? Now, if they now ask us what is the total number of sigma bond that is here, right? So remember, alkenes have 1 sigma bond and 1 pi bond. That is, this double bond is coming with 1 sigma bond and is coming with, at the same time, coming with what? 1 pi bond. So the first thing I will do, I'm going to count. Remember, one of these bonds is equivalent to what? Sigma bond. So this is 1, 2, 3, 4. We have 4 sigma bond, but if you write 4, you fail it. Remember that alkenes have 1 follow-come sigma bond and 1 follow-come pi bond. So therefore, 1, 2, 3, 4 plus the follow-come sigma bond is 5. What about the pi bond? Is what? 1. Okay, now let's take another example. So for example, if you have these compounds and they ask us how many sigma bonds are here and how many pi bonds are here. Remember, first thing, you can't, the bonds that you can obviously see, 1, 2, 3, 4, 5, 6. 6 is equivalent to sigma bonds, right? But it comes with a follow-come. So therefore, this is 8 sigma bonds. Then what? 1 what? Pi what? Bonds. Now moving forward to alkenes or the alkynes. Alkynes has 1 sigma bond and 2 pi bonds. That is 1 follow-come sigma bond and 2 what? Pi bonds. Now for example, if you have these compounds, like this. Okay, if you have these compounds like this, and we are asked to calculate the sigma bonds that are here. Remember, it is 1. This one is equivalent to sigma bond, then 2. And it has a follow-come what? Sigma bond. So this compound contains 3 sigma bonds. What about pi bonds? 2 pi bonds. It contains 2 what? Pi bonds. Alright? So another example is we are given something like this. And the question says, how many pi bonds? This is not sigma bonds now. How many pi bonds are here? Because this is an alkyne. The pi bonds is what? Equivalent to what? 2. How do we know? From the notes. 2. Now, what if the question says, how many sigma bonds are here? Sigma bonds. You say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8 plus follow-come 1. Therefore, it's 9 what? Pi bonds. I hope you do understand. Now, to be sure that you understood everything we just did, now this is a work for you to do. So in this compound, it contains a double bond and a triple bond. And we are asked to find how many sigma bonds are here and how many pi bonds are here. Now, do that for me.